Okay, so now we have to talk about a pipeline. Now, a pipeline is basically a good way to solve a complex problem. What it does is it breaks it down into pieces, so then you can focus on individual problems instead of being overwhelmed by a very complex problem. B, it also allows you to study each problem and test each problem. Um, and by making these separate modules that feed into each other, you can then easily swap improvements. So here we have this pipeline I'll describe in a minute, but you can see there's a piece called Detector. If one of you makes a better detector, we don't have to change the whole program. We can just drop in your preferred detector. So this idea of breaking things down to a pipeline makes collaboration much easier. And so a pipeline is just what it sounds. The data comes in before an object, it gets processed, and then it passes it on. So these things are sequential. Also, if you're a hardware person like me, if you had a different computer doing each of these processes, then you can speed it up because it's like dividing work among 6 people. You've got 6 people working simultaneously. Um, so that's why it's also used in hardware. Okay, so let's go through the pipeline. So the first thing is this microscope provides videos. And from the class, we have dozens of videos, and I just pulled one of them for you to examine. So the first thing is a video is composed of lots of individual pictures, individual images. And so what your detector does is it takes that video, looks at it frame by frame, and tries to separate the objects from the background. And the output will be, I like CSV files, comma separated values. The reason I like those is you can look at them in Excel, which is a quick way to make plots of something. It's the most simplest format, so it's very easy for people to exchange them. I know there's more complicated ways to do it with Pandas and Pickle, if you're familiar with those, but I like CSV because it's human readable, and as I say, you can quickly view it in Excel. So each of these processes has a CSV output, so you can then look at its performance individually. So the detector, as I mentioned, takes the individual objects in a frame and puts a bounding box around them, which determines its XY location and how large it is. And one fellow mentioned shape as a distinguishing feature. Once you have a bounding box around an object, like my face, now you can do a lot of analysis on shape, including area. It also spits out images of objects, which is really important for humans labeling it, because they'll say, oh, that's a stentor. Also, you noticed we had that fancy microscope I mentioned with lasers. That one is good to have the individual images because we can instruct the higher resolution images. So that is the detector. The tracker then looks at all the XY positions of all the objects that the detector generated, and it tries to string them together to figure out, is this still the same object and did it move slightly? And there's a really simple way to do it. If your frame rate is fast enough, if you're sampling quick enough, and the object doesn't move too quickly, if you look at my face for a second, if you see, and this is frame 1, in frame 2, it's slightly moved. But if you look at the 2 frames, there's a lot of overlap. So basically, you just look at an object and look at the previous frame. And if they're overlapping, it's probably the same object. And that'll get you 95% of the way. It gets complicated when you have several objects near each other, but luckily, these are kind of sparse, and in nature, they are very sparse. These are actually lab creatures, so they're much more dense than in nature. Okay, so that's tracking. Basically, you now have the XY location, plus you have an ID. Once you have that, you can also extract a lot of the features now we talked about, the morphological features. Everyone okay with me so far? A head nod. I see a thumb up. Okay, good. Okay, so now we have tracks. We have all the creatures identified, and we're following where they are. And if we have enough of them, we'll call that a tracklet, a segment. We're confident this is the same creature, and there are enough of them that now we're probably getting different poses too. So that's what a segment is. And now with a segment, we can look at things like changing directions. Each creature has different styles of how they move, how they eat, how they avoid predators. And that also can be used as features to distinguish them. And that's where we pull out the dynamic features. And then finally, the end of the pipeline was what our initial assignment was, is to classify these. So now we have static features, the shape, all the morphological features. We also have the dynamics. Some creatures might look the same, but some move. We have a case where two creatures look the same, but one moves a lot faster in quicker changes. So that's a way to distinguish things that look the same. As I mentioned, also, we want to look at the health. We have another project I'm doing with Professor Scara, where we're dosing them with environmentally chemicals you find in the environment, like pesticides, insecticides. And typically, before they die, you can see at sublethal doses, their behavior is changing. With some insecticides, it's as if they have too much coffee. They're just darting all over the place. Others, it looks like they drank too much alcohol and they're slowing down. So, and those are very detrimental to avoiding predators and eating, as I mentioned. So we're studying sublethal doses on behavior. And finally, the holy grail, as I mentioned, is classification and machine learning. And if you've been looking at the jobs wanted list, machine learning is one of the holy grails of industry now, from driving cars to finding injured cells and environmental impacts and so forth. So it's a great skill to have. And if you're doing anything quantitative in your work, machine learning is a way to basically solve black box problems where you can't figure an analytical solution. Now at the bottom, you might see what looks like gibberish. This week's homework is rather easy. It's just filling out 2 questionnaires. And the purpose is it's really our homework, because we're judging ourselves to see how well we're teaching, especially in this new experiment of online teaching. So bear with us and please fill out these 2 surveys. One is more so we can get your background to see what your skills and ambitions are, to see, are we changing your lives, which we hope we are as teachers. The other is I have that shopping list of all those instructions. The reason I'm asking you to go through and saying, are you familiar with any of these? Have you used them? Is because then we can grade ourselves, because we hope to teach you what these routines are and use them in your programming experiences, so we can see how well we did. So if you could bear with us, we're always trying to improve our teaching abilities. Hence, this week is really you judging us, helping us judge us by filling out those surveys. And that's, you're basically going to learn 4 areas. You've probably used NumPy before, which is the array methods. I see a nodding head. Maybe you plotted data. Who doesn't plot data? So Matlotlib, a tongue twister, is what I use at least. OpenCV, a fellow mentioned he uses this for art, is a wonderful machine learning library. So if you, maybe you've used ImageJ, this is for serious users. ImageJ is kind of like cookie cutter. If you want to make your own cookies, this is the library to use. It's amazing, especially because if you set up this thing in Python, usually is if you set up to use one function, you can usually just replace that function with a couple lines of code, which segues well into sklearn. If you could just nod your head yes or no. Anyone use that at all? I'd say a lot of no's. Okay, that's great. sklearn is basically a great way to learn machine learning. And I've just listed a whole bunch. Basically, if you've not done one of them, you probably haven't done any. But if you could just check through all those. what's wonderful about sklearn is if you set up machine learning for one of these methods, you could just replace it with one line of code to try another method. So it's a great way to test a lot of different machine learning algorithms once you set up your training set, your test set, and we'll go through all that.